Hi, good people. Hope you're fine. Welcome to GIS and RS Solution channel. Today is the second and final part of the identification of groundwater potential zones using GIS and RS and ASP techniques. In the first video, I explained you how to perform factors or variables and reclassification of thematic maps for the groundwater potential zones. I have posted the link of the first part below the description section. Anyway, today I am going to show you how you can perform weighted overlay pairwise comparison matrix using an Excel sheet that will give you the output automatically. So let's start. Selection of parameters, controlling groundwater research. In the previous video, I have explained how to prepare variables or factors. You can see over here LULC classified, then soil type, slope, lineament density, drainage density, geology, or rainfall. Pairwise comparison matrix, the 1 to 9 scale of parameters significance, strength of significance from 1 to 9. Here 1 means equal significance, 3 means medium significance, 5 strong, then 7 very strong, and 9 maximum significance. Also there are 2, 4, 6 and 8 in this inter number. So you can see here a pairwise comparison matrix for the ASP based groundwater potential zoning. This matrix will be automatically generated using this Excel. You can see here the ASP Excel sheet. Now I will add these factors in the weighted overlay method. So for that, go to our toolbox and then spatial analyze tools and then overlay and then weighted overlay. So here you can see weighted overlay tool. Now I will add one by one. First I have added LULC, then I will add lineament density, drainage density, soil type. Here you have to add one by one your factors or variables. I'm adding geology, then rainfall. I have added all the factors here in the weighted overlay table. For LULC, how many percentage are you going to give the influence, the weight? By what percent land use, land cover will influence for groundwater potential zone? For all the factors, I will show you how you can get the weight value as percent influence. You can see here a pairwise comparison matrix. This matrix will be generated automatically. This weight, the final weight, I will add here as influence in what percent. So here number of criteria. I have total 7 criteria. Objectives, I'm writing here identification of groundwater potential zone using GIS and RS and ASP techniques. Here I'm going to write criteria, I mean factors, rainfall, geology, then slope, drainage density, LULC, lineament density, and then soil type. I have total 7 criteria. This matrix will be automatically created. Here, open this on, and then you can see here criteria A and B. Which is more important, A or B? You can see here, please compare the importance of the elements in relation to the objectives and fill in the table. Which element of each pair is more important, A or B, and how much more on a scale 1 to 9? You can see here a scale 1 to 9 scale. First is on rainfall. This is A and this is B. So which is important, rainfall or geology? So rainfall is more important than geology. So A, and I'm giving the scale 3 for rainfall. Rainfall is important than geology, and then rainfall or slope. Rainfall is important than slope. So I will give 3 as a scale, and then rainfall or drainage density. So rainfall is more than important than drainage density. So I will give it 5 scale. Then between rainfall and LULC, this will be A and a scale 5, and rainfall and lineament density I will give it 5, and then rainfall or soil. Rainfall is more than important than soil for my study area. So here I will I have given 7. And then geology or slope, which is important for Groundwater potential zone. Geology, drainage density, I will give for geology here 3. A means geology is important than LOLC or slope, drainage density, lineament densities. So you have to give the scale here, which is more important. I have given 5 for geology, then soil. And here slope or drainage density. Slope is important than drainage density. So I think this is equal importance. So I have given on. And then slope or LULC. I think slope is more than important than LULC. So I have given 3. Then slope and lineament density. Slope is important than lineament, so I have given 3. And then slope or soil. So slope is more important than soil, so I have given 5 scale. And drainage density and LULC. So drainage density and LULC both are equal important. So I've given 1. And then drainage density and lineament density I'm given 2. And drainage density or soil, so I have given 3. And LULC and lineament density, uh, you can see here the scale value. Then LLC and lineament density, I will give LLC or lineament for my study area. LLC and lineament density are equally important, so I've given 1. And LLC between LLC and soil I've given 3. For lineament density or soil, which is more important? If soil is more important, then you have to give here B, I mean soil. But for my case, lineament density is important than soil, but both are equal importance, so I have given 1. So this is up to you, your personal judgment and expert opinion. You have to keep the idea of your study area. And here is consistency ratio. For consistency ratio, you have to keep in mind that consistency ratio is less than 0.05 for 3 into 3 matrix, 0.09 for 4 into 4 matrix, and zero point 0.1 for large matrix. If it matches, then the pairwise comparison matrix is said to be consistent. So in my case, I have more than 4 into 4 matrix. So the consistency ratio is 0.05 for my case. So it is consistent. And this pairwise matrix, this table, you can see here, it is automatically generated here. You can see here, this is generated and normalized principal eigenvector. So calculation has done. You can see here it is very easy and simple. You can see here the weights has been automatically calculated for rainfall, geology, slope. From my study area, you can see the weight for every criteria. The highest is for rainfall. That means rainfall is most influential for groundwater potential zone in my area. Now I will just add this weight here as influence. You can generate this table from this Excel sheet for your research paper. Anyway, now I will add this weight and influence in the weighted overlay table. Lineament density, the weight is 5. For drainage density, the value is 9. For soil type, 4. For slope, 13. For geology, the weight value is 25. And for rainfall, it is 38. Maybe there was a mistake. I mean, LLC, it is 6, yeah, and sum of influence must be 100. Yeah. So I have added the weight value here, and evaluation scale that will be 1 is onto 5, onto 5 by 1 for my case. Here you can see the scale value 1 to 5 or value 1 to 5. Now I will give the scale value for the every factors. For that, you have to know the ranks were assigned to the respective parameters considering the field survey experiences, stakeholder consultation, and expert opinions, as well as reviewing the existing literature. So, in here, for the first factors is land use and land cover changes. So, in the forest and agricultural land, runoff is generally less and infiltration is more. And whereas in bare surface and settlements area, the rate of infiltration usually decreases. So water bodies have the highest infiltration rate. So therefore, here for agricultural land and vegetation, I will give the highest rank, and it is a 5. And for agriculture, also I will give 5, the highest ranks. And for bare land, I will assign low rank as 1. And for water body, I will assign highest rank as 5. And the last one, built up areas. For built up areas, I will give the lower rank. I mean 1. And second factor is lineament density. For lineament density, areas with very high lineament density have good groundwater potentiality, and I will assign higher rank due to good porosity and infiltration. And whereas the areas with very low lineament density are considered to have poor groundwater potentiality and assigned lower rank. So I have organized 1 to 5. And then drainage density. For drainage density, runoff, infiltration, relief, and permeability related information are acquired by quantifying drainage density and type of drainage. High drainage density is developed in mountainous relief regions with sparse vegetation and impermeable subsurface. So, high drainage density value is favorable for runoff and low groundwater potential. So, here high rank is given the low drainage density area. So I have arranged 5 to 1. And then soil type. So sandy group soil has a low runoff rate and high groundwater potential, whereas the clay soil group has a high runoff rate and very low groundwater. So sandy soil shows a high infiltration rate, and clay soil offers the least infiltration capacity. So according to my study area, I'm arranging the scale value here. So then slope. Generally, flat and gently sloping areas have high infiltration and are capable of more groundwater recharge, whereas steepy sloping grounds promote high runoff and little or no infiltration. The class having less slope value is given the highest rank due to an almost flat or gentle slope, which associated high infiltration and low runoff, while class having maximum slope value is given the lowest rank due to relatively high runoff and low infiltration. Arranging 5 to 1, 5, 4, 3, 2, 1. Geology also is important for influencing groundwater flow and its existence, and rainfall is also more important as groundwater recharge is controlled by various factors, with rainfall playing a key role since it represents the main source of groundwater recharge. You can see over here identification of groundwater potential zones equation. The calculation will be based on this equation, where Wj represents the normalized weight of the J parameter. Xi refers to the weight of the I class of the parameter. M denotes the number of the parameters, and N denotes the number of classes within a specific parameter. The final output you can classify or ranges from excellent to poor. The highest class is excellent, and the good, fair, and poor. If more on class is generated, then you can write as moderate. Click OK, and you can see here our groundwater potential zone has been done. I'm going to rename it as groundwater potential zone. You can give the name like as this on excellent, good, fair, and poor. As I have 5 classes, so I will add moderate also. So the highest rank is excellent, then good, moderate, fair, and poor. Now I will calculate the area. So for that, we go to attribute table and then add field area underscore square kilometer and type as float, then OK, and then right click on the area square kilometer, field calculator, yes, and then count, multiply cell size 89, multiply 89 divided by 160, then click OK. So area has been calculated here. To validate the potentiality of the groundwater, the present status of several drag wells you can consider as a proxy of groundwater availability. You can use this technique for many similar studies. I hope you enjoyed this tutorial. Many more interesting and useful tutorials will be uploaded one by one. If you don't want to miss this, please subscribe and hit the bell button. And thank you for being with us.